Hi everyone. So let's continue with more concepts on Apache Storm. So to start with, we'll learn stream groupings. So what exactly we mean by stream groupings? A stream grouping tells a topology how to send the tuples between two components. I repeat, stream grouping tells a topology how to send tuples between two different components. Remember that spouts and bolts execute in parallel in the entire topology across the cluster. So if you look at how a topology is executing at a task level, it looks like the diagram that I have shown here on the screen. So there is a spout here which have two tasks, which is emitting set of tuples to bolt A and bolt C. Bolt A in turn have 4 different tasks and bolt C have 2 different tasks. So spout is emitting tuples to bolt A and bolt C. Similarly, bolt A in turn is emitting its own tuples to bolt B, and bolt B has 3 different tasks here. So this is a simple layout of how the entire topology is defined. So there is a spout, there is a set of bolts here, and spout can emit tuples to bolts and bolts in turn can emit tuples to other bolts. Okay, so this is a simple snapshot of how the topology looks, and stream grouping tells the topology how exactly to send these tuples between two different components. So in this diagram, spout and bolt is a component and bolt is also a component. So each of these spout and bolt are considered as components, and stream grouping tells this topology how to send the tuples between these components. Clear? So when a task for bolt A emits a tuple to bolt B, which task should send the tuple to? And that is defined by stream grouping. Okay, so when the task for bolt A emits a tuple for task bolt B, which task of the bolt B to send the tuple to will be defined by stream groupings. Okay, so stream grouping tells the storm how to send the tuples between set of tasks. Okay, stream grouping tells the storm how to send the tuples between set of tasks. So before we dig into different kinds of stream groupings, let's take a look at another simple example on my slide. So this example is of word count topology. So just to brief on this example, there is a spout which continuously keeps on emitting random sentences. Now from this sentence, as a first step, we split this sentence into set of words, and as a second step we count each unique words. Okay, and the second bolt emits the count of each of the unique words in the sentence. So the example is very simple. There is a spout which keeps on emitting a random sentences. That is the first bolt which receives this sentence, and it just splits the sentence into each unique words. And there is a second bolt which takes these words and it counts each unique words in the sentence. So at the end of the topology, you will get each unique words and how many times that word has appeared in the incoming sentence. Okay, so we are just finding out the word count in a sentence. So let's define a topology for this particular example. So as a first step, I instantiate a topology builder class. Okay, topology builder class is basically helping us in defining a topology. Okay, so we instantiate a topology builder class here. Then using this builder object, we are setting a spout. So spout is helping us in sourcing the data to the topology, right? So we are setting a spout and we are giving it a name called sentences. And to implement this spout, we instantiate a class called random sentence spout. So random sentence spout will be a class which will randomly keep on emitting the sentences. Okay. Then after we have defined a spout, let's define bolt number 1. The name given to this bolt is split. The task of this bolt will be just to split the incoming sentence into set of words. That's it. So for example, if the sentence that is received is hello world, this bolt will split that hello world sentence into two different words, word hello and word world. Okay, so hello world will be split into two different words, hello and world. Okay, so this splitting of a sentence will be done by bolt split. Now output of this bolt, that is which is a result of splitting of sentences, so that output will be given as input to another bolt, that is the second bolt here. And what's that bolt name? The name of that bolt is count, and the task of this bolt will be just to count the number of unique words that's coming to it. So word count is a class that will count the set of words that it is getting, that is how many times did a particular unique word appear in a sentence. That count incrementing will happen here. Okay, so just to brief everything again, we'll create a topology builder class. Using this builder class, we're defining a spout whose name is sentences. Okay, and to define this spout, we are implementing a class called a random sentence spout. So random sentence spout will keep on emitting set of random sentences. These sentences will be given as input to the first bolt that we define, whose name is split. Okay, and split sentence class will have definition of this bolt, which will accept this sentence and just split it into words. This set of words will be given as input to bolt number 2, whose name is count, whose implementation is defining word count, which will accept this set of words and it will increment the count of each unique words that it gets. Okay, so this is a simple topology defined. So the important point to mention here is how exactly will we know how the tuples will be passed between different components, and that's with the help of stream groupings. So if you just notice carefully here, this bolt is connected to this spout, and how exactly are they connected? So this spout is connected to this bolt, and now how exactly to pass these tuples? It's by shuffle grouping. Shuffle grouping means the output of sentences spout will be randomly sent to the task of split bolt. Okay, shuffle grouping means that the output of sentences spout will be sent to the task of split bolt randomly in uniform fashion, so that load balancing is done, and the bolt whose name is split will talk to the bolt whose name is count with the help of fields grouping. Fields grouping means all the fields with the same value will go to the same task. I repeat, fields grouping means all the tuples with the same field value will go to the same task. Okay, so only because of this fields grouping, each task will get the same set of words so that it can keep track of the word count properly. Because if the same words goes to different tasks, then it will be difficult for different tasks to keep track of the count, right? That's why the same word should always go to the same task, which is incrementing the count for that particular word, right? So fields grouping is doing that. That is, same word will go to the same task. So the task will just increment the word count. So for example, if you have a hello and world, hello word should always go to the same task who is counting how many times hello has come. Similarly, world word should always go to the same task which is counting how many times word world has come. So fields grouping is doing exactly that. It is just sending the same word to the same task so that each task can exactly count how many times a particular unique word has appeared in the sentence. Yeah? So that is done by fields grouping. So the simplest kind of groupings is shuffle grouping, which sends a tuple to just a random task. The shuffle grouping is used in this example to send the tuples from random sentence spout to split sentence bold. So it has effect of evenly distributing the work of processing the tuples across all of split sentence bold tasks. Okay, so fields grouping is an interesting one, and a fields grouping is used between split sentence bold and the word count bold. It is critical for the functioning of word count bold because the same word should always go to the same task. Otherwise, more than one task will see the same word and they'll each emit incorrect values for the count since each has incomplete information. So fields grouping lets you group a string by a subset of its fields. So this causes equal values for that subset to go to the same task, and only because of the fields grouping we are able to achieve the word count topology, because same word will go to the same task because of the fields grouping. Okay,